What is a galvanic cell? How to how to construct the galvanic cell or Daniel cell? So listen carefully. Here we are taking one chamber. Again, this is another chamber. So here we are taking this is one electrode. Here I will put another color. Here this is another electrode. Then in between you have to join with this is a salt bridge. Salt bridge. So this is connected to the this is a galvanometer. So connected to the other electrode. Again here this is a we have to dip the up to the solution. This is a electrolyte solution. So here electrolyte solution is zinc sulfate ZnSO4. Here we are taking this is another electrolyte solution, another chamber also it is there. So that here also same thing, electrolyte solution is copper sulfate. So here this is a copper rod. This one is a zinc rod. Then this one is a salt bridge. Salt bridge always made up of KCl solution or agar AgNO3. This is a salt bridge KCl solution. So here that always that the left side terminal, this is always act as a anode. This is a negative terminal. This one is a positive terminal. So electrons passes through the electrons move to the left to right, but whereas a current passes through the current I passes to the right to left, always opposite direction. So here, whenever it is a zinc rod, we are applying the power, electricity, then zinc always act as an anode. Anode means zinc, so Zn plus 2 electrons. These 2 electrons passes through the left to right through the galvanometer. The galvanometer, it shows the signal whether it is a movement of the electrons. Okay, so this is a anodic part, anodic reaction. Then cathode always accept the electron, so that here copper plus 2 plus these 2 electrons accept then copper. So here this is a zinc solid, then this is aqueous. Here this is aqueous converted to solid. This is a cathodic part. Cathodic part. Whenever it is released the electron, this anodic part, this is a we are calling as a anode. This one it is cathode. Then whenever it is releasing electron, this is a copper also loses electron. These electron passes through the electrolyte solution through the salt bridge. So this salt bridge enter to the electron, passes through the solution, again accept the zinc. Okay, so what happened? What is use of salt bridge? Salt bridge always to maintain the constant or balance the electron, either anode and cathode. So here, what happened whenever it is losing the electron of anode? This is a flow of electron from left to right. Again, current passes through the right to left. This is a current right to left. This is total galvanic cell. Generally, they are asking a question: which one is anode? Which one is a cathode? Then how to find out the potential? This is a major one. So in this case, which one is anode? Always the left side, that zinc act as an anode and the copper act as a cathode. Already we know that electrochemical series. Okay, electrochemical series. Now I will tell you that a shortcut to how to identify the anode and cathode. So here we have to apply the Nernst equation. E cell equal E naught cell minus 0.0591 by N log of anode concentration by cathode concentration. Anode concentration by cathode. In this reaction, so which one is anode, which one is a cathode, which one is anode, which one is cathode, which one is anode, which one is cathode? Here, zinc act as a anode. So Zn plus 2. So here what happened, we wrote the final reaction, Zn converted to Zn plus 2 electrons, then copper plus 2, then accept the electrons, accept the 2 electrons, it converted to copper. So here we wrote a cell reaction, these two electrons are cancelled, then cell reaction is Zn plus copper plus 2 converted to Zn plus 2 plus copper. This is a final reaction. So this one is a solid, aqueous, again aqueous, ions always aqueous, then metal always solid. Okay, then how to write on the cell reaction? Cell reaction always anode part, salt bridge, both the lines, the double arrow, it shows the double lines, salt bridge, then cathode. So in this case, which is act as a anode? Zinc act as a anode. So zinc, it is converted to Zn plus 2. So that cell reaction, how to write down? Zn plus 2. Okay, then here we wrote again 2 lines. It shows the salt bridge. Then here copper plus 2. This is a copper plus 2 converted to copper. This is a copper. This is a cell reaction. Solid, aqueous, then solid, aqueous, then solid. Okay, so how to identify whether it is an anode? Whatever that cell reaction they will give. So I'm giving the one trick. So I will give the one trick. A, this one is A, B, C. A means anode. B means bridge. Bridge means salt bridge. C means cathode. C means cathode. Is it clear? Anode, salt bridge, cathode. Whatever that they will give the reaction in the examination. So the first one is anode, salt bridge, cathode. A, B, C. You can easily identify. Then whenever they will give the concentration, so anodic concentration by cathodic. So that here we wrote a Nernst equation. This is a Nernst equation. Apply the Nernst equation. So E cell equal to E naught cell, means a standard electropotential 0.0591 by N log anode concentration means Zn plus 2 concentration by then copper plus 2 concentration. Okay, Zn concentration, Zn plus 2. Always you have to take ions, don't take solid. Solid concentration always 1. Okay, then how to get this 0.051? So generally in Nernst equation, E cell equal to E naught cell minus 2.303 by N log of log 10 value. So that we can easily identify. So no need to require the derivation part. They will not ask the derivation part. They will ask only for this type of the questions. So they will give anode concentration, then cathode concentration. For example, they will give the concentration like this: salt bridge, then copper plus 2, then copper. It is a 0.1 concentration. Here 0.01. Then E cell, E naught cell is a 1.2 volts. Then find out the E cell. Generally, they are asking this type of the question. Find out the E cell. How to find out? So you have to apply the formula E cell. This is a formula. E cell equal to E naught means 1.2 minus 0.0591 by N means number of electrons transfer. N equal to number of electrons transfer. So how many electrons are transferred here? 2. So log of anode concentration. What is that? 0.1 by cathodic concentration 0.01. So you have to derive this equation. So here E cell equal to 1.21 minus 0.0591 by 2 log here log 10 we get. So here 1.21 minus 0.0591 by 2 log 10 is 1. So here 1.21 minus 0.0295. So here again 1.2100 here 0.05 sorry 0.0295. So here 50 then 180. So 1 point. Is it clear? So here 1.1805 volts. This is a final answer. Okay. So first you have to find out which one is anode, which one is a cathode for galvanic cell. So here we wrote again, this is a total cell reaction or net cell reaction. Net cell reaction. So again, representation of a cell is anode, salt bridge, again cathode. So cell reaction is anode, then salt bridge, then cathode. So here the simple trick is ABC: anode, bridge, cathode. Now I will give electrochemical series. Just I will give the simple trick. So electrochemical series. So here it depends on the potential values. So here we are taking potassium, sodium, barium, calcium, magnesium, aluminum, zinc, lead, hydrogen. Then after hydrogen, copper, mercury, silver, Au. So here generally up to hydrogen, these are the potential values are negative values. These are the positive values. All negative values always act as a anodes. Then positive values for anodes, then positive values act as a cathodes. So always hydrogen electrode is potentially 0 volts. 0 volts. Hydrogen electrode potential is 0 volts. So then how to identify whether it is at anode or cathode? This is a potassium video. Then I will tell you simple trick. First one is PSBC. Then second one is MAZNZINTL. ZNTL. Then last one is CHOP. CHOP. So here P means that is what is the P? Potassium. S means sodium. B means beryllium. C means calcium. Then M means magnesium. A aluminum. Z zinc. Then lead. This one PB is lead. Okay, lead. Then after that tin also it is there. So I will tell you that PB. I missed that a few. Which one? Zinc is there. Zinc. Then iron, zinc, iron, nickel. So here, sorry for the mistake. Here this is 0 volts. So here zinc, Zn, Fe, iron. I means iron. N means nickel. Then T means tin. Then L means lead. Then after that, hydrogen electrode is 0 volts. Then these are the positive values. These are the negative values. Potassium, sodium, beryllium. Potassium, sodium, barium, beryllium. Then calcium. This one magnesium, aluminum, zinc, iron, nickel, tin, lead. Here hydrogen is neutral. Then here copper, H means mercury, then A silver, then Rm, then P means that is again one more is there, that is a platinum. Platinum. Okay, PSBC, magnetal, CHOP. This is a, you can easily identify whether it is an anode and cathode. So negative values are anodes, positive values are cathode. Is it clear? So in your textbook, you have almost 20 metals, electrode potentials. Very difficult to remember all these things. So that go for this direction. You can easily identify whether it is an anode or cathode. Okay, chalo, write up. Listen, for example, they will give the two metals. For example, zinc. Electrode potential is minus one point minus 0.74 volts. Then similarly, I will give another iron. Iron is minus 0.21 volts. So find out the cell reaction or E cell. Find out చేయమంటారు. E cell. You have to find out E cell. Then how to find out E cell? E cell equal to E right minus E left. Means right side electron minus left side electron. So here how to find out whether it is a right side or left side? Or E cell equal to E cathode minus E anode. E anode. So in this case, both are negative now. Which is act as a anode, which is act as a cathode. More negative, always anode. Less negative, always cathode. If it is positive is there, no need to require. Positive act as a cathode and negative act as a anode. If it is both are negative, so more negative always act as a anode. Then less negative always act as a cathode. So here cathode is minus 0.21 minus of 7.54, 7.74, 0.21 plus 0.74. So here what is that? 0.24 means here 3, 5, 3 volts. This is a E cell. Is it clear?